A very warm welcome, dear students. Hope that you are fine. So our today's question is to find the number of aromatic compounds among the following. So in order to be aromatic, a compound must have 4n plus 2 pi electrons, right? That's actually the Huckel's rule. It should follow Huckel's rule, that is 4n plus 2 pi electrons. So next very important condition is that there should be complete conjugation. There should be complete conjugation. So that means complete conjugation is possible only if we are having a planar and cyclic system. Planar, cyclic and a conjugated system, right? Conjugated system. Then we can have the complete conjugation. So conjugation are of different types. I hope that you have studied already. There is pi-pi conjugation, there is pi lone pair conjugation, isn't it? There is pi-C positive conjugation. So different types of conjugation we are having. Similarly, this complete conjugation is possible only that if all the atoms are sp2 hybridized. So these are the very important conditions which a compound must follow in order to be aromatic. That means it should be cyclic, it should be planar, there should be conjugation, complete conjugation. All the atoms should be sp2 hybridized and it should have 4n plus 2 pi electrons. Then you can tell that it is aromatic. It shows the aromaticity. So let's start with the first one. So the first molecule here it is given. There is one pi bond, that is 2 pi electrons, and then this negative charge. In organic chemistry you have to remember that this negative charge, it actually means the 2 pi electrons, because they are in conjugation with this pi bond. So 2, 2, 4 and 2, 6. So it has 6 pi electrons. It has 6 pi electrons, right? It has 6 pi electrons. So when it has 6 pi electrons, so that means it follows the Huckel's rule, because n value it can be, you can write n value can be 0, it can be 1, 2, 3, etc. So if n value is 0 here, so it will become 2 pi electrons. If n value is 1, so that is 4 and 2, that's 6 pi electrons. So 6 pi electron, it's a Huckel number. I hope you have gone through these Huckel numbers. So Huckel number you have to remember. Huckel number includes 2. So if there are 2 pi electrons, then it will be aromatic. If there are 6 pi electrons, it can be aromatic, right? If it is following other conditions. Then similarly, if n value we will give here 2, so 4 2s are 8, 8 and 2 10. 10 is also a Huckel number. Similarly, 14 is also a Huckel number. So etc. So here Huckel number 6 is followed, and this is cyclic. It is also planar, because this carbon is, it's also sp2 hybridized. Whenever we are having a carbanion, if it is conjugation, so then its hybridization is sp2. So this first one, it is aromatic. Then if we will see the second molecule here, you can see there are 2 pi electrons, only 2 pi electrons. It is positively charged carbon. Here it's also positively, so sp2 hybridized. It's cyclic, it's also planar. So it is following this Huckel number, Huckel rule. So it has 2 pi electrons, so this is also your aromatic compound. Then the next is, it has 2 and 2 4 pi electrons, right? So this was having 2 pi electron, and now this is having 4 pi electron. So when it is having 4 pi electrons, so it is not following the Huckel rule. So when it doesn't follow the Huckel's rule, so it is not aromatic. It's actually anti-aromatic. And then the next molecule, it has only 2 pi electrons and it is cyclic. Complete conjugation is possible there. So when it has only 2 pi electrons, so it's also your aromatic. Similarly, we are having 2 and 2 4 pi electrons. 4 pi electron system is not aromatic, and this is 2, 2, 4 and 2 6 pi electron system, and it is cyclic, planar. Complete conjugation is possible, so it is aromatic. Next molecule is, we are having 2, 2, 4, but see here, this double bond, it is exocyclic. It's outside the ring. It will not be counted here in this conjugation. There isn't complete conjugation. You can see here this carbon is actually sp3 hybridized, this one carbon. So it is not aromatic. It doesn't follow the Huckel's rule. It should be planar. sp3 hybridized carbon, it is having tetrahedral geometry. So how it can be planar? So it is not aromatic. Similarly, this carbon here, if you can see, this is also sp3 hybridized. So tetrahedral, that means it is not completely planar. So it is not a planar system, so it cannot be aromatic, and it doesn't follow the Huckel's rule. Similarly here 2, 2, 4, 2, 6 and 2 8 pi electron system. So 8 pi electron system cannot be aromatic. It's not aromatic. 2, 2, 4, 2, 6. So this molecule has 6 pi electrons. So it can be aromatic. So it is cyclic, it is planar, it is having complete conjugation. All atoms are sp2 hybridized, so it's also aromatic. Then we are having 2, 2, 4, 2, 6. So it has 6 pi electrons. And there is complete conjugation because this is positively charged, this is again positively charged, right? So all carbon atoms are here sp2 hybridized, and it is cyclic, so this is also aromatic. Then this one, 2 and 2, 4. There isn't any lone pair on this boron, right? Because boron has only 3 valence electron and it has shared those 3 valence electrons. So it has only 4 pi electrons, so it cannot be aromatic. So in total we are having 1, 2, 3, 4, 5 and 6. So the correct answer is that there are 6 aromatic compounds among these molecules. So I hope that you have understood. If there is any doubt, any query, you can just comment in the comment section below. Also, you can join our Telegram channel, whose link will be provided in the description box below. Thank you for watching.